Introducing the aspects of gene therapy.
Agents, welcome to the mission Save the Cell. Today, humanity faces diseases caused by defective genes, genetic errors that ordinary medicines cannot cure. But fear not, we have a weapon, and that is gene therapy. Medical science has made tremendous strides, yet many human diseases stemming from defective genes remain beyond the reach of traditional medicine. These illnesses, which cannot be cured by readily available medicines, represents one of the greatest challenges in global health. The potential solution lies in a revolutionary approach, gene therapy. This field is not just a treatment, it's a method that offers the profound hope of either treating or, in some cases, completely curing genetic-related human illnesses. Above, you can see the promise of this technology is highlighted by breakthroughs such as the 2015 research at Harvard Medical School and the Boston Children's Hospital, where scientists used as an improved two vectors, ANT-AT, to successfully restore basic curing in genetically deaf mice. This demonstrated the power of inserting foreign DNA and carried by a viral vector into a patient's tissue to target and eradicate a disease. Inspired by the successes of recombinant DNA technology over the last 20 years, human gene therapy was first realized in 1971. It is undoubtedly one of the most promising, yet complex and potentially controversial medical fields being studied today. Now this here is our lesson objectives. By the end of this lesson, you should be able to, number 1, describe gene therapy and its various forms, and number 2, assess the issue's potential benefits and detriments to global health.
Welcome to the training module. Agents, pay close attention. Gene therapy operates in 3 major ways. We can also call it the approaches of gene therapy. These are the following by Fleshler 2017. First is the replacement of mutated genes that causes disease with a healthy copy of the gene. Now, a gene in the body is broken or not working right. That broken gene is the reason of a disease happens. Scientists can take a good healthy gene version of the gene that is damaged and put it into your cells so it can do the job of the broken one that it can't. Now, second is the inactivation of a malfunctioning gene. When a gene in the body is working the wrong way and causing problems, instead of fixing it or replacing it, scientists simply turn it off so it stops causing trouble. Now, third one is the insertion of a brand new gene to help fight diseases. The body is missing the helpful instructions it needs, so scientists add a new gene that gives your cells extra help. This new gene helps the body fight or control the diseases. But in general, genes can't walk into cells on their own. They need a ride. Now, let's introduce vectors. At present, the most common type of vectors are viruses, modified to carry normal human DNA. Viruses have evolved in a way in encapsulating and transporting their genes into human cells in a pathogenic manner. From Science Daily 2017. They used to be villains, but now they're Uber drivers for genes.
Hello agents, may I introduce you to the 2 types of gene therapy.
Gene therapy. What is gene therapy? Gene therapy is a medical technique that fixes abnormal genes that cause disease. It works by replacing inactive or introducing genes into the body. If a gene is broken or missing, doctors give the cell a new healthy gene. It's like replacing a broken light bulb with a new one so it can work again. Some genes cause problems when they are overactive or not working correctly. Gene therapy can turn off this harmful gene so it stops causing disease, like turning off a switch that keeps causing an electrical shortcut. Sometimes, the body needs extra instructions to fight a disease. Doctors add a new helpful gene that wasn't originally there, like installing a new app on a phone that gives it a new function. There are two types of gene therapy, somatic and germline therapy. First, let us discuss the somatic therapy. Somatic means body. Somatic gene therapy involves the manipulation of genes and cells that will be helpful to the patient but not inherited to the next generation. Somatic gene therapy is a treatment that changes the genes only in the body cells, like for example skin cells, blood cells, or lung cells. Key ideas of somatic gene therapy. It affects only the person being treated, does not get passed on to their children, treats existing patient, targets specific organs and cells, temporary effects, treated cells may die or stop working over time, so the therapy might not last forever. Doctors affix the faulty gene in the specific part of the body that is sick. It's like repairing a machine only in the broken area, not the whole system. Not pass on to future generations, helps only the treated individual. Changes in somatic cells affect only the patient, not his or her future children.
The second type of gene therapy is germline therapy. Germline therapy, which involves the genetic modification of germ cells or the origin cells that will pass the change onto the next generation. Changes the genes in reproductive cells, example sperm, egg, or early embryo. These changes will be inherited by the future generations. Key idea: the genetic changes are permanent. They are passed on to future generations, like their children and grandchildren. Note: unknown long-term effects. Since the changes are permanent, any mistake can be passed on to all descendants. Stem cells are what we call the mother cells of the body. Think of them as a starter cells that can grow into many different types of cells, like muscle cells, blood cells, or even brain cells. What makes them special is that they can keep multiplying and renewing themselves, which helps the body repair and maintain its tissues. Now, the importance of stem cells. Number one, it helps in body repair and regeneration. One thing that makes stem cells unique is their ability to stay flexible. This means they can change into different kinds of cells depending on what the body needs. Because of this, they play a big role in healing injuries, replacing damaged cells, and supporting medical treatments like gene therapy. Gene therapy is a medical technique where doctors change or fix a person's genes to treat a disease. It works by adding, removing, and correcting a gene inside the cells so the body can function normally. In simple words, it is a method of repairing the body by fixing the genes that cause sickness. Where do stem cells come from? Stem cells come from different sources. So stem cells come from several places in the body. But the two main sources we usually talk about are embryonic stem cells and somatic or adult stem cells. Both kinds can develop different cell types, but they come from different stages of life. Let's first dive into the embryonic stem cells. Embryonic stem cells derived from 4 to 5 day old embryos in the blastocyst stage. So embryonic stem cells come from very early stage embryos around 4 to 5 days old. So a blastocyst is an early stage of an embryo that forms about 4 to 5 days after fertilization. It looks like a tiny hollow ball made up of cells, and this is a stage where embryonic stem cells can be taken. In simple words, it is a very early form of an embryo, like a small ball of cells that developed a few days after the egg and sperm join. These embryos are often extra or unused embryos formed in vitro fertilization clinics or IVF. In vitro fertilization is a process where an egg and sperm are joined outside the body, usually in a laboratory. After they form an embryo, the embryo is placed into a woman's uterus to help start a pregnancy. So in simple words, it is a way to help people have baby by fertilizing an egg in a lab, then putting the embryo into the mother's womb. So it has a high potential for developing into almost any cell type according to CROSSA 2013. So these cells are very powerful because they can turn into almost any kind of cell in the human body.
Now let's move on to somatic or adult stem cells. So what is somatic stem cells? It can be found throughout the body after embryonic development. It is located inside many types of tissues. Can be found in the brain, bone marrow, blood and blood vessels, skeletal muscles, skin, and liver. Usually stay in a non-dividing or resting state for years, activated by disease, injury, or tissue damage. Now, imagine somatic stem cells as the quiet heroes living inside your body. They are not the flashy, do-everything embryonic stem cells, but they are reliable, loyal, and always ready when things go wrong. Somatic or adult stem cells live in many organs: your brain, bone marrow, liver, skin, and even your muscles. Most of the time, they stay asleep, like soldiers waiting for an alarm. They can stay in this resting state for years. Now, what can they do and their limitations? Let's start first of what they can do. They divide or self-renew indefinitely. They can turn into different cells with types. They can turn into different cell types within the same organ. Can help repair or regenerate damaged tissues. They can help repair or regenerate damaged tissues. So their limitations may sometimes become other types of cells or limited flexibility, usually restricted to become cell types from the original tissues. But some studies suggest that they can convert into other cell types under special conditions. What happens if injuries or disease strikes? Activation. They wake up, start dividing, and repair the damage. So their powers include: first, self-renewal. They can make more copies of themselves endlessly. Second is differentiation. They can turn into different types of cells. Second type is differentiation. They can turn into different types of cells, usually from their home organ. For example, bone marrow stem cells can produce many kinds of blood cells. Scientists used to believe they were strictly limited to their original organ, but new evidence shows they might be more flexible than we thought. Under certain conditions, they might even become other types of cells. Example, if you cut your skin, adult stem cells in that area activate and help create new skin cells to close the wound. They're your body's built-in repair team.
Now, let us go to the bioethics of gene therapy. There are ethical issues of gene therapy. First, let me ask you a question. How can good and bad uses of gene therapy be distinguished? Gene therapy is generally considered good for therapeutic purposes, like treating genetic disorders or diseases, but raises concerns for non-therapeutic enhancements like selecting desirable traits. Second, who decides which traits are normal and which constitute a disability or disorder? Gene therapy decisions involve medical, scientific, and societal considerations, with debates on whether to focus on treating severe conditions or exercise caution due to complexity and risk of altering the human genome. Third one is, will the high cost of gene therapy make it available only to the wealthy? Gene therapy's high costs limits access, with only 5 to 10% of patients who could benefit from it currently able to access it. Efforts to make it more affordable include outcome-based pricing, cost-effective manufacturing, government negotiation, and financial assistance programs.
Number 4. Could the widespread use of gene therapy make society less accepting of people who are different? Possibly yes. If gene therapy becomes common, society might begin to expect everyone to meet certain ideal genetic standards. This could increase discrimination against people with disabilities or natural differences, making them feel less included or valued. It may also create social pressure to fix traits that are simply part of human diversity. 5. Should people allowed to use gene therapy to enhance traits like height, intelligence, or athletic ability? This is controversial. Supporters argue that people should have the freedom to improve themselves if technology allows it. Opponents warn that enhancement could create unfair advantages, widen the gap between rich and poor, and lead to a society where worth is based on engineered traits. Many believe gene therapy should focus on treating diseases, not boosting human abilities. Germline therapy. So germline therapy involves altering the DNA of reproductive cells, sperm, eggs, or early embryos. Because these changes occur in germ cells, the modified genes are passed down to all future generations of the individual's descendants. So here are the key points to explain. So it targets heritable DNA, unlike somatic therapy, which only affects one person. Its goals may be to prevent inherited diseases before a child is even born. It is more permanent and far-reaching because the changes spread through family lines.
To sum it up, gene therapy is a groundbreaking medical approach that treats diseases by fixing, turning off, or adding genes. It can be applied to body cells in somatic therapy or to reproductive cells in germline therapy, which affects the future generation. Stem cells play a key role in repairing and replacing damaged tissues. While potential benefits are enormous, ethical questions, high costs, and societal implications make careful consideration essential. Gene therapy offers hope for conditions that traditional medicines can't cure, but also challenges us to think about the responsibilities that come with such powerful technology.